Hi YouTube, myself Ritvik Joshi. I'm a student of VIT University, Chennai campus, a first year electronics student. Today I'm going to show you how to solve some of the questions related to basic AC circuit analysis. The book from which I'm going to take the questions is Fundamentals of Electric Circuits by Alexander Sadiku. I'm going to solve question number 14 to 20. I'll put the link for the other questions in my description below. So let's start with the question number 14. The question number 14 refers to simplify the following expressions. Here it is given various complicated equations which involve use of rectangle as well as polar form and conversion of rectangle into polar and vice versa. Let's start with A part. It goes of 5 minus j6 minus 2 plus j8 divided by minus 3 plus j4 into 5 minus j plus 4 minus j6. Let us go to the solution of this. First of all, I want you all to know here j, which is the complex part, refers to the iota. It is same as iota I, which has a value of square root of -1. So that means whenever you multiply two j's, it will be j square and it will be equal to -1. So simplifying the first part, A part, which is the A part, we get 3 minus j14 divided by -7 plus j17. We have done nothing but basic operations of multiplication, addition and subtraction. Now the question comes how to divide the two phases. Here we use the conversion of rectangle into polar form. This 3 minus j14 upon -7 plus j17 is given in the rectangular form. Converting this into polar form, we get 14.318 angle minus 77.91 degrees divided by 18.385 angle 112.38 degrees, which is equal to 0.7788 angle 169.71 degrees. Converting this again into rectangular form, we get minus 0.7663 plus j 0.13912. Conversion of rectangle into polar and polar into rectangle form requires the use of calculator, a scientific one. Similarly, we do the B part. The question is 240 angle 75 plus 160 angle minus 30 into 60 minus j80 divided by 67 plus j84 into 20 angle 32 degrees. The first term is given in the polar form. We convert it into rectangular form, which gives us the value 62.116 plus j231.82 plus 138.56 minus j80 into 60 minus j80 divided by 67 plus j84 into 16.96 plus j10.5983. Multiplying this whole term with 60 minus j80, where I again refer to j square as -1, we get 24186 minus 6944.9 J divided by 246.06 plus 2134.7 J. For dividing, we first convert the upper numerator as well as the denominator into polar form using a scientific calculator. Divide them. While dividing, the R part, which is the modulus part, is divided directly, whereas the theta part, which comes in the angle, the theta, which is in the denominator, goes on to the numerator with a negative sign on it. So we get minus 1.922 minus J 11.55. For squaring and giving the roots to the phasors, we use a method in which we first convert everything into phasor. For squaring, we directly square the modulus part and multiply the theta with 2, and for converting it into root, we directly take the square root of the modulus part and take half of the value of the theta. So we get 20 angle 20.6 the whole square. No, I'm really sorry. It will be 22.36 angle 63.43 degrees divided by 5 angle 53.13 degrees the whole square into 11.18 angle 26.56 degrees into 25.61 angle 51.34 degrees to the power 1 by 2, which gives us the value 20 angle 20.6 into 16.923 angle minus 12.38, so the answer will be 334.93 plus J 48.32. Let's move on to this next question. It is simply evaluating the determinants. It's nonetheless the same as the previous question. We have to solve the determinants using some properties or directly by opening from either a row or a column. Let's go on to the A part. It is 10 plus J6, 2 minus J3, minus 5 and minus 1 plus J. We know how to open up the determinant and find the value of it. We multiply the diagonal elements and subtract it with the other diagonal elements. That is A11 into B22 minus A12 into B21 is equal to delta, where delta is the value of the determinant. So we get here 10 plus J6 into minus 1 plus J1 minus 2 minus J3 into minus 5. Again solving it normally by addition, subtraction, multiplication, we get minus 6 minus J11. For second part, we have the polar form, which we cannot add directly. So we first convert it into a rectangular form and then use arithmetic operators and convert it into polar again, which gives us 120.99 plus J 4.415. For the C part, it is the 3 by 3 determinants, which requires the use of the property delta is equal to, here we open up using the first row, which gives us the value equal to minus 1. For transforming the sinusoid into phasor, we first see whether the amplitude is always positive, whereas the theta, which will be the angle inside the cos or sine, must be under cos. What I mean to say is the sinusoid must be in the form of a cos of omega t plus phi, where phi lies between minus 180 to plus 180, and a is always greater than or equal to 0. For doing this, let's begin with the first question. It is minus 20 cos 4t plus 135 degrees. Here we see the amplitude is negative. We know that cos of theta minus 180 degree is minus cos theta. So we take theta as 4t plus 135 degrees and we get 20 cos 4t minus 45, which is of the form of a cos omega t plus phi, where omega is 4, phi is minus 45 degrees, and a is 20. The Phasor form will be a angle minus phi, a angle phi. Therefore, the Phasor form is 20 angle minus 45. Similarly, the second question, 8 sine 20t plus 30 degree. Here we see that this sinusoid is in the sine form. To convert it into cos form, we know that cos of theta minus 90 is sine theta. Therefore, we get 8 cos of theta, which is 20t plus 30 degrees, minus of 90 will be equal to 8 sine of 20t plus 30 degrees. Hence we get 8 cos of 20t minus 60 degrees, which is again of the form a cos omega t plus phi, where phi is minus 60 degrees, omega is 20, and a is 8. The Phasor form will be 8 angle minus 60 degrees. The third part is the combination of two sinusoids. Hence, convert them separately into Phasor form. Take the rectangular form of both, perform basic arithmetic operations, and convert it into polar again. Going on to 17th question, we see here two voltages V1 and V2 appear in series, so that the sum is V equal to V1 plus V2. V1 equal to 10 cos of 50t minus 60 degrees volt and V2 equal to 12 cos of 50t plus 30 degree volts. Find V. Basically, we need to add these two phasors, and the relation given here is V equal to V1 plus V2. Hence, for adding the phasors, we first can write the phasors into polar form, which is A, which is 10 for V1, angle phi, which is phi is minus 60 degrees for V1, and 12 angle 30 degrees, which is for V2. Converting the polar forms into rectangle form, we get 5 minus j 8.66 plus 10.39 plus j 6, which will be equal to 15.392 minus j 2.66. Converting it into polar form, we again get 15.62 angle minus 9.8 degrees, which is the required answer. For converting this polar form into Phasor form, we see that the frequency of the two sinusoids added are same. Hence, the omega will be 50, A is 15.62, and phi is minus 9.805 degrees. The basic form is A cos omega t plus phi. Relating the both, we get 15.62 cos 50t minus 9.8 degrees volt. Similarly, in question 9.18, it wants us to obtain the sinusoids corresponding to each of the following phasors. Again reminding you, the sinusoid is a cos omega t plus phi, where a is always positive and phi ranges from minus pi to pi. V1 of t can be directly written as 60 cos of t plus 15 degrees. V2 can be first converted into polar form, which will be 10 angle 53.13 degrees, and then written as 10 cos of 40t plus 53.13 degrees, as omega is given as 40. I1 is given as 2.8 e to the power minus j pi by 3 amperes, and omega is equal to 377. The e to the power term is nothing but cos t minus omega iota sin t. Here we use the De Morgan's theorem, which says e to the power iota theta is equal to cos theta plus iota sin theta, and e to the power minus iota theta is cos theta minus iota sin theta. Using this, we get I of t equal to 2.8 cos of 377t minus pi by 3 amperes. I2, first we convert it into polar form and then write I2 of t as 1.3 cos of 10 to the power 3t minus 112.62 degrees. Question number 19. Using phasors, find 3 cos of 20t plus 10 degrees minus 5 cos of 20t minus 30 degrees. Since the frequencies are same of both the phasors, we can add and subtract both these phasors. Hence, in A, it will be 3 angle 10 minus 5 angle minus 30 degrees, which requires the same arithmetic operations of converting polar into rectangle, adding, subtracting, multiplying, and then again converting rectangle into polar, which gives us 3.32 angle 114.49 degrees, and writing that into phasor. Similar question, 40 sin 50t plus 30 cos of 50t minus 45 degrees, which requires us to convert first 40 sin of 50t into cos function, which gives us 40 cos of 50t minus 90 degrees plus 30 cos of 50t minus 45 degrees, converting into polar form and then again into rectangular form. We get 21.21 minus j 61.21. Converting into the polar form, we get 64.78 angle minus 70.89 degrees. Hence, it will be equal to 64.78 cos 50t minus 70.89 degrees. In C, it wants 20 sin 400t plus 10 cos of 400t plus 60 degrees minus 5 sin of 400t minus 20 degrees. The 20 sin 400t term can be written as 20 cos of 400t minus 90 degrees, whereas minus 5 sin of 400t minus 20 degrees can be written as 5 cos of 400t minus 20 degrees minus 180 degrees. As we know, cos of theta minus 180 degrees minus sin theta. No, I'm really sorry. Minus 5 sin of 400t minus 20 degrees can be written as minus sin 400t minus 10 degrees can be written as minus 5 angle minus 110 degrees, which gives us 9.44 angle minus 44.7 degrees. Hence, it will be 9.44 cos of 400t minus 44.7 degrees. Moving on to 20th question, we have a linear network has a current input of 7.5 cos 10t plus 30 degrees amperes, and voltage of output of 120 cos 10t plus 75 degrees volt. Determine the associated impedance. Associated impedance is basically Z. It is represented by Z and is equal to V upon I. Hence, we know I equal to 7.5 angle 30 degrees, V equal to 120 angle 75 degrees. Therefore, Z equal to V by I. We get 120 divided by 7.5, which is equal to 16, and 75 minus 30 degrees, which is equal to 45 degrees. Converting it again into rectangle, it is 11.31 plus J 11.31, which is the required answer. So YouTubers, thank you for watching my video. If you like this, please like and comment my video. I'll post the link to other questions on the AC circuit analysis in my description below. Subscribe my channel. Thank you.